Distance questions with a bit of an unusual bent. Usually when we get a distance question, we know 2 points and we don't know the distance. But it is possible to get a question where you know the distance and one of the details of one of the points you don't know. I'd like to look at this 2 different ways, one graphically and one purely from a formula point of view. If I just plot the points that I do know, I've got a point -3a, so it's out here at -3, but I don't know whereabouts along this line it is. It's somewhere along that line. My other point is at exactly 3, 1. 3, 1, just there. Now I can start to think about a distance between these points. Well, what I know is that all distances are based upon Pythagoras. So I'm looking at a distance between the two x values of 6 and between the y values. Well, now what's it going to have to be? I've got 10 being equal to the square root of 6 squared plus something else squared. Now 6 squared is 36. That means this bit must be 64. So what was the distance there? The distance must be 8. So the distance along this line, we've got 6 that way. Going up and down here, that's got to be 8 from that point there in order to make a triangle. So this is 1, that must be either 9 that way, or it could be, what was that, 1 minus 7 that way. And it turns out that both of those are answers. So my answers would have been -3, 9 for that point, or -3, -7. Now sometimes we can find that approach a little bit confusing, so let's look at a purely formula-based approach as well. What is the distance formula? Distance is equal to the square root of, well, it is just Pythagoras, so the x distance squared plus the y distance squared. So in this case, if we start substituting in, we know a distance, which I've just scribbled out. Distance. That's 10. We know 2 x values. That is 3 minus 3. And we know, kind of, 2 y values. And those are 1 minus a. So when I start my substitution here, you'll see that I quickly end up with something very much the same as what I had in the previous question. 1 minus a squared. Now when I go to solve this, I've got a little problem here in this thing being a square root. So if I go to solve here, I'm going to have to square both sides in order to get this out of the square root. So I end up with 136 and 1 minus a, all squared. I could expand this and solve it as a quadratic, but that's not what I'm going to do in this case. I'm going to go for a slightly shorter solution. I'm going to move that 36 over the other side, taking it away gives me 64, 1 minus a squared. I'm going to take the square root of both sides, giving me plus or minus 8. And then I'm going to subtract 1 from both sides. So I end up here with minus a is equal to plus or minus 8 minus 1. Now, what are the two answers that gives me? Plus 8 minus 1 is 7, minus 8 minus 1 is minus 9, and I've still got minus a here. Now I've got to do this for a, not minus a, so multiply the whole thing through by negative 1, and I get a is equal to negative 7, and a is equal to positive 9. Just the same as I did on the other side.